The first form of engine mentioned in the syllabus for aeronautical is internal combustion. Key points: it's air-cooled, because water-cooled engines you need to take water up in the air, which is weight. So it's an air-cooled motor. Think like a motor mower, where there's all the fins outside to get rid of the heat. The cylinder's in the middle where the piston travels up and down. There's fins all around the outside that give you an increase in surface area, which gives you increased rate of heat loss to the atmosphere. So, in an aircraft, there's common Cessna has got a flat six engine where there's 6 cylinders, 3 on each side of an engine. There's all the cooling fins to get rid of the heat, and the propeller on the front. So you've got 6 cylinders, 3 on each side, laying flat, facing each other. 4 stages in the internal combustion engine. Intake, there's 3 things. There's intake valves, there's exhaust valves, and there's a spark plug in an engine. First stage, the intake valve opens, the air and the fuel mixture gets sucked in. The fuel is vaporised in a carburettor or a fuel injector, depending. The piston travels down. When it's down, second stroke, piston pushes up, compresses the gas, as we said, increased pressure, increased temperature. Third step, the spark plug ignites the gas, or a fuel injector injects fuel and ignites it. Usually that happens just as the piston's getting to the top, and then by the time the fuel ignites, the piston's just starting to move down. So ignition is the third phase, drives the piston down rapidly. That's where you get your power from. The momentum carries the crankshaft round. The crankshaft's this purple thing I've drawn in the middle. Pumps this piston back up while the exhaust valve's open and the exhaust gas disappears. That's the basic operation of an internal combustion engine. It's used here in aeronautics, air-cooled, low altitude. A standard engine runs at around about 3,000 metres to 4,500 metres, which is 10 to 15,000 feet. It can't run much higher than that because the air pressure is somewhere between, at sea level, it's 101 kilopascals. 10,000 feet up, 3 metres up at 70, 15,000 at 60 kilopascals. So we're looking at about 2/3 of sea level air pressure. You can't really run the propeller aircraft much higher for 2 reasons. One is it runs out of air to suck in. It just cannot get enough air to physically run any higher, as well as that propeller needs air to drive the plane forward. The higher up you go, the less there is for the propeller to work on. So really, for a standard combustion engine, can only go a little bit up in the air because it needs air for the propeller. The propeller needs air, the engine needs air. You've probably heard of turbochargers in cars. You can put a turbocharger on these engines in planes. A turbocharger just increases the pressure of that air coming in. Means you get a little bit more volume, and you might be able to run up to 6,000 metres, 20,000 feet. So, but that's about the limit of internal combustion engines. It's limited by the amount of air that the propeller, go back 100 years to the 1920s, also called an air screw because it used to drive itself through the air. Air screw propeller needs air to work. Cannot work above around about 3 kilometres to 6 kilometres up. That's your internal combustion engine.